Let's solve the following inequality. It's an inequality because we have the inequality symbol less than involved here, and also linear because if we look at the highest power of x, so that's 1. So let's begin. So what we'll do, we'll transpose 4 from the left hand side to the right hand side, and x minus 5 over 4 from the right hand side to the left hand side. So this should give us x minus 1 divided by 3 minus x minus 5 divided by 5. So this is going to be less than. The inequality sign should not change, and that will be negative 2 minus 4. Right. So we will combine the terms x minus 1 over 3 minus x minus 5 over 5 by multiplying both sides with the least common multiple of 3 and 5, which is 5. So let's write it down. The least common multiple of 3 and 5, so that's equals to 15. We'll multiply both sides with 15. So that means we have 15 times x minus 1 divided by 3 minus 15 times x minus 5 divided by 5. And here we have negative 2 minus 4, so that's 6. So we have 15 multiplies to negative 6. Now what about the inequality sign? Is it going to change? No, it's not going to change because here our number 15 is positive. And whenever we multiply with a positive number, then the sign of the inequality does not change. That means if A is greater than B, and let's say we multiply with a positive number C, then AC will be greater than BC, provided C is a positive number. Right. So that means this will stay as less than. Now 3 times 5 is 15, so we have 5 multiplied to x minus 1 minus, so 5 times 3 is 15. That gives us 3 times x minus 5. So this is going to be less than. 15 times negative 6 will be negative 90. Now we have 5x minus 5 minus 3x plus 15 less than negative 90. 5x minus 3x, so that will be 2x. Negative 5x plus 15, so that will be positive 10 less than negative 90. We have 2x less than, so we'll transpose 10 from the left hand side to the right hand side, so that will be negative 90 minus 10. So 2x less than negative 100, and we'll now divide both sides with a positive number. If we divide with a positive number, then the sign of the inequality is not going to change. So that means x is going to stay as less as negative 50. So this is the solution to a given linear inequality, and if we want to express it graphically, then what we'll do, we'll consider a number line with the value 0 and negative 50. And since our solution is all values of x which is less than negative 50, so that means our solution will lie to the left of 50, and here 50 is not included, so we'll put a bubble here. So this is the graphical way of representing the solution for the given linear inequality. And there is also another way, which is the interval form. That means in the interval form, we'll have values of x going from negative infinity to negative 50, and this is going to be an open interval. Here negative infinity is unbounded and 50 is excluded, so that's why we're using an open interval here. So these are the ways of representing the solution to our given linear inequality.